I'm going to go over the post-lab for Lab 1, the effective pH on a food preservative. The first question is just asking you to report the data from the experiment. Make sure that you're using your measurements, not the recommended amount that's listed in the lab book. And also make sure that you're reporting all of the digits, all of the numbers that you got from the balance. Don't do any rounding here, write everything down. Second question, you're going to be ultimately calculating the percent yield of the benzoic acid. This is going to take you through the four-step process to get to percent yield. You're going to start by calculating the millimoles of sodium benzoate. Sodium benzoate is the substance that you started with. You have the amount of sodium benzoate in grams. So you're going to be converting the grams of sodium benzoate into moles, and then you'll be converting the moles into millimoles. Just as a reference, 1 mole has or is equal to 1,000 millimoles. So this gram to mole conversion, we haven't done anything like that in quite a while. You might need to look back to your notes from Gen Chem or just do a quick Google search to remind you how to do a gram to mole conversion. You are going to need the molecular weight of sodium benzoate, and your lab manual, your lab textbook provides you with the molecular weights. You don't have to look them up. For this experiment, the molecular weights are in table 1.1, which is on page 44. So once you get the millimoles of sodium benzoate calculated, then you're going to calculate the theoretical millimole of benzoic acid. And this is asking you to make reference to the equation at the top of page 44, which I have copied right here. So this is the equation that you want to be looking at. Now, the first thing that I want to talk about, there's this notation, this six-membered ring with a circle inside of it that we haven't covered yet in class. That notation is just a shorthand abbreviation for alternating double single bond. So that's all that notation means, and you'll see it quite a bit in the lab book. This is the sodium benzoate, and this is the benzoic acid. And so to calculate the millimoles of benzoic acid, you're just going to do a millimole to millimole conversion. This is another thing that you learned how to do in Gen Chem, so you might need to reference the stoichiometry stuff from Gen Chem. The millimole to millimole conversion is the exact same thing as a mole to mole conversion, so that's kind of what we called it in Gen Chem, mole to mole. And to do a mole to mole conversion, you need to use a balanced equation, and you need to use the stoichiometric coefficients from the balanced equation. This one's pretty straightforward because the stoichiometry is 1 to 1. Once you get your millimoles of benzoic acid calculated, then you're going to calculate the mass of benzoic acid. That's going to require you to take the millimoles of benzoic acid, convert those into moles, and then convert those into grams. Again, the molecular weight is in table 1.1. And like I said, be nice to yourself. It has been a really long time since you've done these types of calculations, but it'll all come back really quick. Just, look it up, remind yourself how to do it. Last but not least, you're going to calculate the percent yield of benzoic acid. That's going to be your actual yield divided by your theoretical yield, multiply by 100 to make it a percent. Your actual yield is the amount that you actually made. So it's this number right here. And your theoretical yield, that's what you just calculated. It is possible that this might be over 100%. You might get over 100%. If you do, when you do, sometimes students are tempted to just turn these numbers around so that you get a percent yield that's under 100%. Don't do that. It's always actual on top. It's always theoretical on bottom. Sometimes it's over 100%. That just means you did a bad job. Not a big deal. Then you've got 3 questions from your lab textbook. Question number 1, exercise number 1 on page 46 is asking you to compare the physical properties of sodium benzoate and benzoic acid. Find something different about the two, some physical property that one has that the other does not, and write that down. There's a lot of correct answers to this problem. Exercise 2, page 46. And also exercise 4, page 46, they're pretty similar. These two questions are asking you to think about the acid-base nature of this particular reaction. Exercise 2 references you to equation number 1, which is on page 42. Now, the way that you're going to find equation number 1, you're going to go to page 42, and then you'll see there's a few balanced equations, and they have some numbers in parentheses to the right of them. Like, I can't remember how many there are. I know there's at least 2. Equation number 1 is going to be the one that has the number 1 to the right of it. Now, the question, exercise number 2, is asking you to take a look at that equation, and it wants you to label the strong acid, the weak acid, the strong base, and the weak base. So maybe we have something like this. We have molecule A reacting with molecule B, turning into molecule C and molecule D. To answer this question, I think the first thing that you should do is identify which is an acid, which is a base on both the left-hand side and the right-hand side. So don't worry too much about strong versus weak. Just focus on finding your acids and your bases. The left-hand side is going to have 1 acid and 1 base. The right-hand side is going to have 1 acid, 1 base. You might need to reference the definition of acids, look up the Bronsted-Lowry stuff to help you identify which is an acid and which is a base. We covered it at the beginning of the year, and we also covered it in Gen Chem. So let's just say that we decide that this is our acid and this is our base, and this is also our acid and this is also our base. As a reminder, again, you're going to have 1 acid on each side and 1 base on each side. You can't have an acid plus an acid or a base plus a base. Once you get your acids and your bases identified, then you can move on to deciding which one is strong and which one is weak. This is something that we did at the beginning of the year. Just kind of as a reminder, we learned how to compare compare strength of bases using the REO trick. So what you want to do is begin, let's say we're going to begin with the bases. You want to just focus on your 2 bases and use REO to help you decide which one of these is more stable. The stable base is going to be the weak base, and the unstable base is going to be the strong base. With REO, remember you want to apply these letters in order, meaning that the most important variable is A, and A stands for atom with the formal charge. So you want to look at which atom has the formal charge in this base versus this base, and which one makes the most sense for that formal charge. Specifically, we learned atom with the negative formal charge. So once you get these identified, let's say that I decide that this is my strong base, and this is my weak base. Once you get those identified, then you're going to move on to your acids, and you're going to do the same thing. You can use REO also to compare acids. We only learned REO in the context of bases. So when we learned REO, we defined atom with the negative formal charge. When we're applying REO to acids, we're looking at atoms with a positive formal charge. Acids have positive charges, bases have negative charges. So use REO again. The stable thing is the weak thing, and identify which is which. Then last but not least, exercise number 4, page 46. This is asking you to take a look at this equation right here. This is the equation from this experiment. I'm just going to copy it down here, bring it down here. And remember, SB stands for sodium benzoate, not strong base. And this is our benzoic acid. Question number 4 says, what would happen if you then raise the pH by adding aqueous and NaOH? So what it's saying is, hey, you did this experiment, and then what would happen if you took that product, I'm just going to get rid of everything else there, you took this product, the benzoic acid, and you added NaOH. What's going to happen? What are you going to make? So it wants you to predict the products of this reaction. It wants you to label them as the strong acid, strong base, weak acid, weak base, using the same steps that you used up here. And it also wants you to explain like what that would look like to your eyes if you did this. What would it actually look like if you were observing this actually happening in the lab?